So what I wanted to actually go through was to give you a flavor of each of those families of solutions, just a little bit more in detail, and also a short demo of how we are implementing and these solutions at our customer environments as well. So we'll give you a real demo as well to get a flavor of how these things actually sort of work in practice. So starting with the analyzer solutions, as I mentioned earlier, we've got different varieties of solutions, such as a WES cluster, WES cell, WES site analyzers, which allows the technology operations or the radio optimization teams or transport and core performance management teams to actually do more from that perspective in NOC/SOC environments. So this offers improved speed and efficiency around performance degradation and handling. It drives continuous improvement at the area and the performance level across clusters, country or city level, and then allows you to actually sort of rank all these area sites with scorecards. So fundamentally, I'm actually sort of focused, I'm starting with RAN, performance management and optimization and closed loop automation capabilities at the minute. Then I'll actually extend it across to the various other domains, and then also actually have a wrapper on the service quality management and service impact analysis as well. So that's the way I intend to actually take you through this journey of the solutions that we offer to our customers. So just to continue on the WES cell and cluster analysis, it uses a structured approach to performance management through multi-RAN GIS-based performance visualization, as well as a comprehensive geographic/GIS-based drill down to actually identify the top list of worst offenders for harmonized across multiple technologies and multiple vendors as well. So as you can see, the WES cell analyzer workflow sequence actually sort of consists of going through the holistic view of the performance-related KPIs on a country level, then actually sort of drilled it down into a county level, where you can actually sort of see the individual KPIs and statistics. And this is an example that I've actually sort of taken for a end-to-end VoLTE across multiple vendors, as you can see, from S1 to X2 interfaces and PDCP and RLC layer, allowing you to actually provide the various statistics on accessibility, returnability, mobility, including intra and intra-eNodeB handovers. Also actually sort of touching on the radio backhaul as well with S1 and X2 bottlenecks identification. So that's pretty much actually sort of the core of that solution, where we provide those capabilities. And added to that, we also focus on proactive monitoring as well through our machine learning and traffic profiling and intelligent baselining techniques, where we've got dynamic thresholds where we actually learn the past data from the various different trends across multiple network elements and correlate that in order to actually make those specific decisions, as well as to identify the RCAs. So we've got different algorithms where we have embedded these things, the different algorithms into our traffic profiling and machine learning techniques as well, through single threshold, breach intensity detectors, adaptive thresholding through standard deviations and so on, which have been well proven in our customer base. So what I wanted to actually sort of show you was a quick demo of how the WES cluster, WES cell, WES site analyzer in action. So as you can see from my screen, firstly, a performance management and an optimization engineer in NOC/SOC environments logs into the GIS, isolates the list of worst performing offenders based on the color coding that we would have actually sort of designed already, and then looks at the top list of N cells. It could be 10, 20, 50, depending on what the health index is. And by the way, all of these capabilities are actually completely off the shelf, where we have actually sort of designed hundreds of thousands of KPIs across the various different domains and vendors and technologies, as you can actually see, which are then combined into a health index KPI. So you don't really have to actually be looking into hundreds of all these KPIs across multiple vendors and multiple technologies, where we have already bundle them into some kind of health index KPIs, as well as the triggers based on the traffic patterns of the past and the current data, as you can see over here. So over here, we are actually sort of showing a specific vendor-specific health index that we have combined the various different KPIs, isolated those list of worst offenders, and then the suggested views, which is basically an automatic option that we embed within our solutions, obviously comes with the various different KPIs in order to isolate those top list of 15 worst offenders or 20 worst offenders, if you like, which can then be passed to your optimization teams or trouble ticketing and fault management teams and so on as well, by providing the details of the worst cell analysis over here, which are completely actually sort of drilled down from a GIS perspective. So, and then all the different KPIs, including RRC failures, RAB establishment failure rates, and so on. And it kind of actually sort of goes through, which are all completely embedded into our solution as provided for multi vendors and multiple technologies, which are harmonized across these vendors as well. So just to actually go a little further on the worst cluster analysis, so we saw the worst cell analysis on a specific region. If you wanted to look into the worst cluster analysis to actually get a holistic view of the overall KPIs across the specific cluster or region, we also offer those solutions to have those KQIs, which are then actually rolled from KPIs on the specific network elements, and those clusters can then be filtered out to see which are the worst performing clusters, and the health index for each of those clusters, as you can actually see, a 4G cluster across Germany, for instance, over here, and we've got 3 clusters which we have identified that are worst performing, and we can then actually sort of automatically drill down into that specific 4G cluster within a specific region to actually look at the average health index, and also we can look, and all these statistics are also actually integrated with our machine learning and traffic profiling techniques, as I mentioned before as well. So then, this is all a curated list of algorithms that are actually embedded in order to filter out the top list of worst offenders, if you like, right? And then all these dashboards containing these pre-aggregated KPIs are embedded as well, like paging success rates, data volumes, and data throughput, and so on, within the worst cluster analyzer, in order to pretty much actually provide NOC engineers to, on a near real-time basis, filter out the top list of worst performing offenders, and then you can then actually sort of focus around the next steps, if you like, on automation or optimization of these regions and different cells that you want to be actually doing. So that's that's just a flavor of the pre-integrated out-of-the-box solutions relating to worst cell, worst site, and worst cluster analysis, and all the different multi-vendor harmonized KPIs. And one of the key things is, as I keep mentioning, harmonization, because you're not just actually sort of looking at filtering out all these cells on a per vendor or a per technology basis. If you wanted to actually sort of look at the worst performing offenders across 2G, 3G, 4G, across various different vendors, it kind of actually gives you that ability to provide that in our curated dashboards, of course. So the next thing is to, as we go up the pyramid, from monitoring to analyzer solutions, we get into the area of root cause analysis, which systematically provides you with network improvements to address also the service bottlenecks as well. As you can see, the root cause analysis actually addresses coverage, mobility, network faults, and capacity-related bottlenecks. And I've taken an example of all of the different areas where the suite of products, if you like, Proactor with our automation platform allows you to actually model something called autoflows, where you can model the various different algorithms, and we provide out-of-the-box algorithms for addressing the root cause analysis capabilities in order to identify the overloaded cells, or if it's actually sort of through network faults, through hardware or software failures, or addressing the outages when it comes to mobility, to handover failures and inter-system handover failures, as well as when it comes to capacity, looking at the channel element and PDCCH failures and so on the radio, as well as we are able to offer solutions on the transmission and the core as well, which we will actually see those automation solutions a bit more in detail in a minute. So that's how it basically works. So we offer these standard off-the-shelf solutions to provide worst cell, traffic, and capacity RCA, which provides you not only with a curated list of multi-RAN worst-end offenders, as we saw in the previous solution, but also a structured approach to providing what those root causes are. So as you can actually see, firstly, we are able to actually understand what is the health index summary on a daily trend on a specific region where the clusters are actually failing. And then once after the health indices are isolated to look at the worst performing offenders and where we have considered the top list of worst performing cells, then we can then actually go into the area of why these specific cells or clusters are actually failing. So I've taken an example of a VoLTE mute call, and we have implemented the VoLTE mute call and VoLTE drop call solutions across various different customers, as you can see, where, for example, finding out mute calls in a VoLTE environment is actually pretty difficult. So we have developed a whole bunch of autoflows and algorithms to intelligently detect those mute call on a near real-time basis, where you could actually have a whole bunch of issues for mute call based on uplink and downlink issues being detected, or IPRB utilization and so on. And that's where I want to actually move next to address systematically solving the VoLTE challenge for mute and drop call RCA. As you can see, we actually cover all vendors in order to identify the VoLTE mute calls. We provide off-the-shelf analysis dashboards, which also includes all the root causes such as uplink and downlink causes, as well as the PRB utilization and the capacity-related information as well. And these are all some subsets of the root cause detection methods that we actually use in order to actually identify what the problem is automatically. As you can see, this also includes not only the uplink and downlink issues for external and internal interference and overshooting cells, but also other issues such as S1 fluctuation and X2 fluctuations and ping pong and delayed handover and high PRB utilization as well. So we've got a whole bunch of methods that are actually embedded within this solution, which provides you with a curated list of like 5 trigger KPIs, 100 analysis KPIs, and 4+ dashboards for you to identify the problem of these VoLTE mute calls across all vendors as we speak on coverage, quality, mobility, and outage and capacity related KPIs. So that's just an example of the drop call. So we have families of solution which actually does VoLTE mute call analysis automatically, and then families which does the drop call analysis. As you see with DCR, we look at the guaranteed bitrate, cell capacity and availability, PDCCH overload due to max RRC connected users. And then, as we actually move into the coverage areas, such as the downlink and the uplink external interference issues, and also due to ping pong and handover failures as well, where we can actually sort of detect these drop calls. So one of the key things that we've also done with some of our customers is not only through performance management to find out the VoLTE mute calls, but also enriching this information from the probes as well to find out where exactly the cells are actually sort of facing those mute calls based on some of the customer handset related information that's enriched into our platforms too, which improves the accuracy of our offering. As you can actually see, the VoLTE root cause analysis provides a whole bunch of those root causes in our dashboards on the pre-checked outage issues, backhaul issues, coverage issues, capacity issues, and quality issues. And these are all the issues that are actually sort of reported from our dashboards. And as you can see, it's actually sort of quite comprehensive, ranging from S1, X2 instability, handover success rate issues, PU-SCH optimization, high retransmission content, PCI conflicts, and so on and so forth as well. So just to give you a brief demo of our VoLTE mute call and drop call analysis, as you can see, we move on from the worst cell and the worst cluster analysis to actually sort of to filter out the top list of worst N offenders. And from that point onwards, we can then actually look into the root cause analysis across all technologies, of course. Over here, I've just actually sort of chosen VoLTE, but we can do obviously 4G, mobile broadband, 3G, and 2G cases too. The reason why we've actually picked VoLTE is actually it's quite challenging and comprehensive that we have developed for our DCR, the drop call analysis, and the mute call RCAs as well. So as you can see, it gives you a curated list of the top N worst offenders where the mute calls are actually detected in your environment, and it goes through the drill down capabilities as well. So you can then actually sort of look into things such as why you've actually sort of got based on S1 fluctuation or high PRB utilization and so on, or delayed handover capabilities that are the ones that are actually causing mute calls for these specific cells. So the next thing is to actually sort of isolate those top list of worst offenders, and also drill that down to specific cells to look into the individual KPIs that are actually sort of creating that problem within that root cause, right? You've got uplink issues, you've got uplink interference issues, the coverage issues, and so on. And for the specific cells, you can then look into the specific KPIs which are actually causing that specific problem. And you can do that on an area level, or a cluster level, or a cell by cell level, based on the filtering and the KPI thresholds that we apply to the problem. So as you can see, it kind of actually sort of goes through, and it's quite scalable as well. So with one of our key operators, we are actually addressing about 500,000 cells, and intelligently detecting the faulty mute calls on a every 15-minute interval, right? So you can then actually sort of imagine the scalability and the performance of our faulty mute call and the drop call analysis dashboards, providing you with those capabilities within our product suite as well. So that's the faulty mute call analysis and drop call analysis, root cause analyzer. Then we move into the areas of cross-domain analysis, moving on from RAN to adding backhaul and transmission. So we offer solutions to our customers which address multi-vendor 2G, 3G, 4G RAN with layer 2 VPN connectivity. And that kind of actually is a typical end-to-end network comprising of MPLS routers, cell-side gateways, and MSTPs with multi-service transport platforms with radio backhaul and so on. So how do we actually sort of address it? We have solutions such as RAN backhaul analyzer, which actually combines the capabilities and the performance related KPIs and the inbuilt algorithms between radio and backhaul performance management through scorecards, and looking at the path level to link level, as well as allowing you to actually sort of navigate to links to paths to the RAN sites to quickly isolate those degradations, whether it's actually a radio problem or a backhaul problem or a transmission problem or a core problem, because we are able to model the topology through configuration management tools and enrich this with our data. We are able to quickly isolate this beyond the radio and the RAN level as well. So that's basically the outcomes are like integrated RAN and backhaul and transmission performance management and optimization. It enables teams with integrated multi-domain capabilities for improved triaging times and dispatch accuracy. And it also allows you to actually rapidly identify the backhaul paths and links which are severely congested, and isolate these issues from the radio cell sites too. And pretty much actually follows a very similar style of the root cause analyzer and the worst cell and the worst cluster analysis through ranking method, and also dynamic and static penalty scores with curated dashboards in it, which we have embedded with a whole bunch of scorecard KPIs and analysis KPIs across various vendors and technologies. So just to give you a kind of a real scenario where we have got IP RAN backhaul with transmission and core in it, this is the way we actually sort of model some of the parent-child relationships with, which allows us to model the entire end-to-end topology and addressing the bottlenecks specifically for our customers, if you like. So we have implemented things such as isolating these issues on the radio level. Then you actually move into the mobile access serving gateways, and then cell site gateways with VLAN interface throughputs. And then the solution also allows service providers to look into things such as the IP SLAs from Cisco, for instance, to look into the round trip times and delay and jitter, in order to also correlate that with the network performance statistics. Also, we enable traffic versus active testing as well. Because we've got a comprehensive list of SNMP libraries, we can also actually do some sort of active testing through our capabilities too. So I'll give you a short demo on how do we isolate the bottlenecks between the multiple domains very quickly, and also address the optimization capabilities as well in order to fix these problems. So as you can see, where we've got the multi-domain analyzer, to start with, and I'm going to actually sort of look into the RAN IP cross domain, and a pretty similar chart that I was actually showing you before, which has a multi-technology site, including VoLTE, 2G, 3G, 4G, radio base stations. These are all the 3 different technologies on a specific site where on the top. And then we have correlated that with the Huawei packet transport network throughput. So that's the first point of backhaul, which is actually the one which is causing the issue, not the radio, which we saw earlier. So we saw the radio capability, radio-related statistics over here with the 3 different cells for 3 different technologies, which are actually carried over by a specific backhaul, and then the transport network with all the IP routers and the IP interfaces takes over to the edge of the network. So we are able to actually correlate because we've got the end-to-end topology for this specific customer, and we are able to model these hierarchies within the tool. And this allows you to actually sort of quickly isolate those issues for the specific radio sites are actually sort of are experiencing the congestion-related problems, not because of the degradation of the radio, but because of the backhaul. And that's what we are able to actually sort of show over here. Right, and it extends to the various different MPLS routers and IP routers and so on as we actually sort of go along. And as I mentioned before, with including the IP SLAs, where we are able to actually sort of simulate some artificial traffic from the shadow routers, which can also provide you with other statistics such as max response times, the jitter and the delay related statistics, in order to correlate that with the radio and the backhaul and the transmission and the correlated KPIs too, in order to actually sort of quickly isolate those issues in near real time. Yeah. So that's cross-domain analyzers analysis capabilities. Then we move into the next level of the pyramid with automation solutions enabling open loop and closed loop automation capabilities. So fundamentally, I'll actually sort of start with some scenarios on radio automation and then actually move into CS core and PS core automation capabilities that we are actually providing to our customers today. So just to actually start with radio automation, one of the fundamental use cases that we actually provide are sleeping cells and outage detection capabilities, and pretty much on a real-time basis we are able to actually sort of look into the sleeping cells not only during the last 15 minutes but also using some intelligent traffic profiling algorithms over the last n number of days and weeks in order to identify what those sleeping cells are. And this is one of the key differences from other traditional tools such as SON and so on. So, and these, once we have actually identified these sleeping cells, including the correlation of faults within those cells, we are able to also instruct the SON tools with their configuration management capabilities to go and reset the specific cells automatically as well. So as you can see, we have implemented this in some of our customers where we have traffic trended and traffic profiled capabilities in order to actually sort of look at the sleeping cells on a specific day of specific hour of the day, if you like, and trend it and actually sort of make further actions through configuration management tools of SON or any other CM platforms which the operators basically use. So the next use case is we look at automatic identification of these outages based on various different techniques that we've embedded, like looking at the cell site outage detection, neighbor distance ranking, the importance of those specific neighbors, selecting those candidate cells automatically and looking at if the restoration can actually be detected, and a whole bunch of different things as well, which we embed into our algorithms, such as code utilization, power utilization, uplink and downlink RSSI. And on the right hand side, you can see a whole bunch of these parameters that we take into consideration in order to identify where the congestions are automatically detected. And the recommendations we are also able to provide recommendations as well, such as increase the cell individual offset, QRX LevMin capabilities, or any of the other CM parameters. So this is one example where we are actually sort of showing you where we have automatically identified those cells, looked at the root causes, And for those specific root causes which are actually suffering from congestion and so on, we have invoked our recommendations module in order to provide those specific recommendations in order to alleviate the congestion, if you like. And as you can see over here, at that specific point in time when the CM changes were actually applied, the KPIs actually sort of rapidly begin to improve. And I've got a short video at the end of this this specific section to show you those capabilities as well. So as I mentioned earlier, not only do we actually sort of have a comprehensive radio and RAN automation and optimization solutions, but also CS core and PS core automation as well. So as you can see, I'm giving you a quick flavor of 2G, 3G, 4G data customers on SGSNs and MMEs and GGSNs for core automation too. So just to give you an overview of the AutoFlow catalog for the automation that we have got on the core, it kind of actually sort of ranges from authentication analysis to simultaneous capacity utilization to SCTP link failures to VoLTE mute calls on the core. The VoLTE is just not, when you have challenges on radio, it's just not on the radio, but also on the CS core and PS core, including the circuits which fall back on the IMS capabilities, where we can actually bring all of those things end to end and identify the problem, for example, on VoLTE, right? And these are some of the specific solutions that we've got on the packet core and circuit core automation as well. Just some examples of those screenshots, but I'll actually play you a small video of how we are offering these automation capabilities and RCA capabilities for CS core and PS core in a minute. So this is an example of MSC authentication failures and automatically identifying the map failures and routing info failures, or looking at the EOS codes with receive traffic load failures and so on automatically, and actually providing some recommendations to see how these things can be fixed as well. So that's just an example where we've got a couple of those AutoFlow and RCA cases for MSC authentication success rates and MSC authentication attempts, which goes through a whole bunch of the AutoFlows, as I actually sort of mentioned before, in order to identify what the root cause of the problem is, all the way down to the port level, if you like, on SCTPs and SCPs and so on and so forth. And this is an example not only on the node level, but also on the root level as well. I know some customers actually sort of struggle quite a bit in order to actually sort of identify the intra-root bottlenecks between the core network elements. And we've got some solutions by modeling these AutoFlows within our platforms off the shelf for these network elements in order to identify these problems too. And that's an example of degradation identification and root causes. So that's let me just actually go with a small short video of our automation solutions in action. So as you can see, I'll start with some of the radio capabilities of how we do end-to-end automation with closed-loop capabilities, and then show you the example of CS core and PS core automation too. So over here, as you can see, this is an example of special event management in order to alleviate congestion on 4G and 3G simultaneously. First, it detects we provide pre-packaged solutions, as you see over here, which actually contain a whole bunch of AutoFlows and all the curated list of KPIs that we know are the ones that actually have an immediate impact when we have to actually sort of look into those root causes and fix them for the various different levels and the triggers. So these are all the pre-built, off-the-shelf, automated workflows that are actually built by the telco expert group within Mycom OSI and provided to our customers, which can be automatically deployed, if you like. And of course, there is a level of localization that we have to undergo when we deploy this in your site. But that's fundamentally how we actually provide these AutoFlows. And once these AutoFlows are actually implemented, deployed, you can see the platform automatically actually sort of comes with a list of all the worst offenders, as well as the operations to be carried out as well. So these operations can actually sort of range from resetting a cell, or it can actually be changing the cell individual offset, or it can be making all types of different recommendations, including QRX, LevMin, and so on and so forth. So that's basically a state engine, which provides you with those automatic capabilities. And once they get applied onto the network, you can actually see at this point in time when it was sent, when these commands were sent to the CM engine and those parameters were actually applied, you can see the changes, how positively we have actually impacted the network in that specific instance. And over here, I'm kind of actually showing you an example of a CS core and PS core autoflow, where, as I mentioned in my slides earlier, and this is a typical example of an autoflow that's actually modeled over here. We are showing you the MSC performance and the authentication autoflows, which can be triggered in real time in order to look at the various different EOS codes to actually identify what the root cause of the problem on MSCs or GGSNs or SGSNs or serving gateways and so on the evolved packet core as well. So that's all the end-to-end automation solutions that we've got. So as you can see on MSC, for instance, you're able to actually sort of look at good authentication success rates or whether things are actually sort of really bad on the performance of the routes, finding out what the RCA is and all the different KPIs which are actually off the shelf and inbuilt as part of our solution too. So then we move into the area of service quality analysis and service impact analysis, which is pretty much actually going from a network to the service domain, where we significantly get into the next notch of looking at the service models and how the network-related KPI degradations are actually impacting the service KPI degradations, if you like. And this is where we capture the entire networks of network and service topology, which consists of different technologies, different domains, and so on. As you can see, this is an example of an IPTV service that we actually monitor for our customers, right, which contains multiple topologies, multiple data sources, different use cases, and we provide off-the-shelf KQIs and dashboards. Some example data sources actually sort of include mobile voice data, international voice data and internet, IPTV, geolocation, inventory, and topology. So we've got capabilities to actually sort of capture information and emitters, as we call them, which are the vendor technology interfaces for the various different tools such as probes, XDR, CDRs, and traces, and so on. Also correlate that with the performance management and configuration management data to provide the service level KQIs on top. So one example that I'm actually sort of giving you is based on our implementation of the IPTV service to our customers, if you like. As you can see, this is an example of some sample use cases where we are able to actually look at the channel unavailability and problem with catch-up TV or video on demand, poor viewing experience, and unavailability of audio and video. So those are the specific use cases that we look on a specific channel level, right? You know, if your Sky Sports is actually failing for your customers, right, we are able to actually identify the specific channel level degradation, which consists of the end-to-end network from TVRO to encoding to BMX to FCC to layer 3 aggregator and so on. So all on a service level. We are actually we have moved from network level to a service level, for instance, with our service impact and service analyzer solutions, right? So how is that made possible? Firstly, we have to obviously sort of get all the topology and the end-to-end configuration of that service, where it actually traverses through the various parts of the network into our platform in our service quality management engine. And once you've got the service model, then we are able to actually have specific service level KQIs. And over here, we are actually showing where the IPTV channels are actually degrading on a specific region, as you can see, and also correlating the fault management alarms and trouble tickets as well as part of our solutions. And you can see how the health index and the KQIs for service level monitoring capabilities are actually sort of quite different, where we are looking at the user quality, the impacted channels and the impacted services, and where, you know, over here, this is one example where we are actually sort of providing you with the list of all the channels which are provided by the specific service provider and seeing how individually they are able to actually provide this quality of service to their customers. I'm sorry, I'm actually sort of moving quite fast, but you know, we can always actually sort of discuss in specific sessions more in detail later on as well after this webinar. So as you can see over here, you can see the list of all the specific channels that are actually offered by the service provider to their operators, right? And to actually understand where the problem lies, basically. For example, Sky Sports or BBC Al Jazeera, in this case, for one of these Middle Eastern operators, where we are actually providing the service quality management capabilities and identifying where the exact problem is on a country level, and then actually sort of looking into how their customers are actually impacted from that perspective as well. Similarly, and the way we go about doing it is to actually get information from our own PM platforms or external probe or other trace engines such as Sandvine and eProbes and SolarWind and so on and so forth, to then actually ultimately have a manager of managers from a service quality management perspective, if you like, to aggregate these KPIs from the individual KPIs. Not only do we do service quality analysis, but also have comprehensive capabilities on service problem and service impacting capabilities as well, right? So we look into the specific service impacting capabilities by looking into where what the root causes are for that specific service to be impacted. As you can actually see, I can actually sort of look into a root cause identification, if it's a problem with a compute node, if it's actually a full 5G service, like a virtual service for IPVPN, for instance, which are actually hosted on an NFV. It also provides you with the capability, with the dashboards of what the root causes are, that there is actually a RAN VNF, which is actually sort of severely impacted, and that's the one that's causing. So we are able to actually provide root cause analysis on hybrid NFV networks to actually go down to the underlying infrastructure level as well. A whole range of service quality analyzers and service impact analyzers are provided by us to our customers, and you can actually see, you can benefit from a whole range of these service quality and impact analyzers, as you can actually see across the various domains, such as IPTV, IPVPN, IPPBX, if it's corporate fixed, if it's consumer mobile, it could be 2G, 3G multi services, or if it's consumer fixed services, it's IPTV, catch-up TV or video on demand, and all the way operating on the service level, and then actually drilling that down to the network level as well. Moving one level up the pyramid, these are all some of the closed-loop hybrid NFV automation solutions that we provide to our customers today. As you can see, a whole host of physical network function performance monitoring with virtual network function performance monitoring with virtual USN and virtual unified gateways, where we have actually integrated that with the underlying multi-VIMs such as Cloud Opera and Huawei-based interfaces with underlying OpenStack and so on, and extending that across to the virtual core as well with virtual USN and virtual UGWs. So some of the use cases that we address to our customers today are in the areas of unified service assurance with hybrid NFV with closed-loop automation to go instruct the MANO as well. And some of the evolving use cases such as network slicing and VCP use cases that we have done for our customers more recently. So closed-loop automation with service assurance as a brain. This is actually one of the key things where we integrate with the MANO, and we are completely agnostic, and service assurance actually sort of serves as a brain in order to instruct these changes to the orchestrator, if you like, right? And we are also involved in a lot of standards and bodies and TMF catalysts, and this is some of those examples that I'm actually giving where assurance-led MANO capabilities, where we instruct the MANOs to do some scale out, or if it's actually 5G network slicing use cases, we do things like dynamic bandwidth scaling requests and so on in order to differentiate between the multiple different slices between ultra reliable low latency communications and so on. So all of those things are also actually possible to our solutions.